Okay. Okay, good morning. It's really a wonderful day today because we have already finished 6 online keynotes, and now we are going for our today's. Before that, I just want to inform you that what is the schedule already with you. So now we'll start our second inaugural keynote, or I can say the next second day keynote by Dr. Anirudh Gautam, and in this room in the Gargi. And then after that we have offline plenary keynotes in 2 rooms, in Gargi as well as Moitri. Gargi means this room, and in the other room. So 3 plus 3, another 6 offline plenary keynotes will be there. So after the offline plenary keynotes, so there will be tea break. So our tea break today is little late, and then our session 3 paper presentation schedule is scheduled, and which will be held from 12 to 1 p.m. and today in 4 different rooms. This Gargi Auditorium, Venue 1, Venue 2 Maitri Auditorium, Venue 3 Safety Center Seminar Room, and Venue 4 Industrial and Systems Engineering Seminar Room. After that, lunch will start around 1:15, and then there will be 3 track workshops. The track workshops will be in 3 different rooms, like in the Subir Chaudhary School of Quality Reliability, where prognostics and health management related workshop will be held, and that is basically 2-hour workshop, 1:45 to 3:45. It will be hands-on kind of activities. And then second workshop is epidemiology of road traffic injuries, will be held in this room, Gargi Auditorium. And third workshop is econometrics method, mainly from the data, business economic data analysis perspective, that will be held in Moitri room. Then after that we have tea break, and after tea break at 4 o'clock we will be starting our panel discussion. Basically we want to understand in the panel discussion that what actually we have learned in this 2-day session, and how we will take it forward from the from, I can say, from center's perspective, from IIT's perspective, from industry's perspective, from the nation's perspective, and from international perspective. So then after that there will be valedictory and closing ceremony from 5:30 to 6:30 p.m. So after closing we will be having high tea and further networking from 6:30 p.m. to 7:30 p.m. in the Vikramshila foyer. So with this, and in fact I do apologize to Dr. Gautam, because we are really sorry that we are overshooting the time by 15 minutes, and I'm sure the audience all and the participants and other dignitaries today here, you all will definitely pardon us for this late, I think some kind of delay in starting each of the sessions. Actually, in between there was some technical glitch. We have started on time, but there is certain technical problem in online, so that's why this 15 minutes overshooting has happened. And our keynote will be, this keynote will be, second day keynote will be presented by Dr. Anirudh Gautam. You have seen him yesterday also, and I request my friend Professor Chaturvedi to introduce Dr. Anirudh Gautam.
Thank you, Professor Jyotishamati. Before inviting, in fact, I had to wait around 10 years to introduce him on such kind of dais. He's a very good friend of mine and very passionate person in the area of RAMs. In fact, we interacted through that on so many occasions. So before inviting Professor Gautam on the dais, I am really feeling honored to introduce him on this occasion. Dr. Anirudh Gautam, currently serving as the Principal Executive Director, Research and Technology at the Research, Design and Standard Organization, RDSO, and Adjunct Professor at the Department of Electrical Engineering at IIT Kanpur, and continues to contribute significant to the advancement of locomotive technologies and innovation, and I am adding ramps. His role at RDSO involves overseeing and directing research and technologies advancement in railway systems and standards, further cementing his dedication to the driving forward the realm of locomotive engineering and development. Recognized for his, although he has received several awards, but recognized for his outstanding contribution, Dr. Gautam has received several awards from the Ministry of Railways, including prestigious national awards for outstanding service conferred by the Ministry of Railways. Today, he will be sharing his experience on implementation of ramps and PHM for the rolling stock of Indian Railways. We are welcoming Dr. Anirudh Gautam. Please.
Thank you, Professor Chaturvedi, Professor Mehti, and all my friends gathered here. Thankful to the video team here and the sound and the video, the team here dedicatedly working since yesterday. So can you put my, okay. I'll be this one. Okay. So this is the topic of my presentation: Indian Railways transitioning to predictive maintenance for high safety and availability. So I'll go through this presentation, and I welcome any questions in between or at the end of the presentation. Oh, sorry. Okay, before I begin on the actual presentation, let me just share the objectives of Indian Railways. And since quite a few of you are users of Indian Railways, you travel in trains. So Indian Railways is trying to provide a very good service in terms of reducing the travel time by at least half. So if you are traveling from A to B in 8 hours, it is the endeavor of Indian Railways to reduce it to 4 hours, because there is a growing demand and there is a growing competition from other modes of transport, especially the air. Then we are also looking towards increasing the carrying capacity of the goods trains, and which means that heavier loads, heavier axle loads. And there is a very strong demand from the customers for on demand. For example, if I have to travel from, let's say, Lucknow to Delhi, the passengers' demands are that I should be able to catch a train every 1 hour or 2 hours. So on-demand passenger trains, just like your EMUs or local trains. Then we are looking at incorporating the road transport flexibility into the railway operations, transport operations. Roads, as you know, are very flexible. So if we can have that, and there's a lot of work going on in that direction as well. Then a very important thing to make the bottom line blue is that we have to increase the availability of the assets, rolling stock and infrastructure, so that we can use it maximum number of times. And a good figure for rolling stock, for example, is about, it should be more than 95% availability. Safety, of course, is a very, very important and very crucial for railways. And we are also looking to towards the export market, to have, we can provide products and services to the export in the other countries. And the Gati Shakti has given a Gati Shakti master plan. Prime Minister Gati Shakti master plan has given a very strong role to the railways to increase its share in the passenger and the freight transport sectors. So as you know that Indian Railways has a large inventory of assets. We have close to 3 lakh wagons, about 60,000 coaches. Now it is, I think, 70,000 coaches, 11,000, 12,000 locomotives, 80,000 kilometers of track, 1.5 lakh bridges, 7,500 railway stations, 70,000 signals with 2.25 lakh signal aspects. So everything has to be treated as an asset. 50,000 kilometers of OFC increasing every day, and and 65,000 kilometers are, it's increased to 90,000 now, of course. So it's increasing. Our inventory is increasing every day. And if you look at the finance part of it, so this is the finance part. So we have a total earning of, this is figure for 2021 in crore. So we had almost 13,000 crore, 1,30,000 crore for as the earning, and we spent close to 45,000 crore in repairs and maintenance of our assets. So this comes to around 34.6%. The global benchmark is 10%, at most 15%. So we are looking at a very big gap, and that decides our bottom line, the Indian Railways bottom line. How to achieve these objectives? And as Professor Chaturvedi said, I've been working with him for the last 10 years and with IIT Kharagpur. And we are trying to work out ways and means by which we can transition to predictive maintenance. At present, the Indian Railways, they have a very detailed method of scheduled maintenance. So we do maintenance after so many kilometers or so many ton kilometers, and that is very fixed and that is very sacrosanct from the safety point of view. But we want to come to predictive. So we need to, for that to happen, we need to adopt the RAMs as a structured system on railways. Then a structured PHM, which earlier we used to call condition monitoring, has evolved into a bigger science, and it is called as prognostics and health management, and there are standards for that. And then we are looking at the whole picture of asset management. There another standard ISO 55,000 for that. So it's a big task considering the inventory of assets, and then we have 12 lakh employees. So it's a big order. Now I'll skip that because you are all, I think most of you are from the field of RAMs, but these are this is RAMs: reliability, availability, maintainability, safety. They are all probabilities. Reliability, that a system will perform its required function over a given period of time under stated operating and environmental conditions. Availability, that a system is repairable system is operational at a given point of time. Maintainability, that it can be repaired in a specified amount of time. And safety is ability not to harm people. So this is I'll go fast on this. It's just the introduction to that. Okay. So this is life cycle approach of RAMs, and there is a specification specific to railways for the RAMs, and it's called RAMs 50126 part 1 part 2. So this is a typical V cycle starting from concept, system definition and operational context, risk analysis and evaluation, and specification of system requirements, architecture and apportionment of system requirements, design implementation, manufacture, integration, system validation, system acceptance, and operation, maintenance, performance monitoring, and decommissioning. So this is a typical, it's called V model. So quite a few of you must be familiar with this V model. So the concept of RAMs or PHM comes right from the concept and goes till the decommissioning. So to say that once I manufactured a thing and then I will implement RAMs or PHM is not done these days. And similarly, this is PHM, prognostics and health management. So I'm able to, there are two parts here. One is the diagnostic part. The second thing is the prognostic part. Diagnostic is I'm able to find out the problem, and prognostic I can estimate the remaining useful life. And then ultimately I have the maintenance management or the health management. So this is PHM. Sorry, this is sometimes get stuck. So this is the PHM cycle. So you have the design cycle and you have the operational cycle, and they feed into each other, and the captions are self-explaining. I need not dwell on that. I'll come to the case studies. So this is one of the typical models. So the RAMs and PHM, they have fused together. And RAMs, as you know, the S is for safety, and PHM. So there's a fusion of these two sciences. And world over, people are using relevant softwares. There are some very excellent software where all this knowledge has been stored together, and it makes it easier for you to actually make digital models, RAMs models, PHM models, and start working from day one, rather than devoting your time into building models by writing, Python codes, or So, given the complexity of the problem. For example, in the railways, in addition, you see, I've got so many assets, such a large inventory. Each diesel locomotive, for example, has got another 5,000 parts. So it becomes extremely difficult to do it from the scratch. So people do make use of, and for example, NASA, even DRDO, our DRDO, some of the labs, and in China. So all this is becoming the norm rather than the just one of a situation. So these are, and then this is a failure diagram of power system. So this we have done, and so we make these models so that this knowledge, so operator gets retired, or the technician gets retired, or the engineer gets retired, so his knowledge goes away with him. This is the way to capture this knowledge and then pass it on. So this is also a type of a knowledge management, in addition to providing you the solutions and all. So this is the architecture. I'm coming to the case study. This is the architecture that we are having. So if you, yeah. So I'm talking about the rolling stock. Now let me give you the difference between rolling stock and the infrastructure. So whatever rolls which has got wheels, coaches, wagons, locomotives, they are called as rolling stock. And whatever is stationary, for example, the tracks, the signals, the overhead lines, buildings, they are the infrastructure. So we divide, railways divides its assets into two categories. One is the rolling stock, the second is the infrastructure. So here I am talking about the rolling stock. I deal with the rolling stock. So we are looking at fitting these rolling stock with certain sensors, using existing sensors to gather their health condition, and also we have wayside sensors to sample the health of the rolling stock as it is passing by. And then we take it to the cloud, and this is the operations center. We planning to build it in, we already have a center in New Delhi, for example, in Kishanganj. So we'll be augmenting that. And then we have a RAM server, an analytics server, and so we do the analytics. So these servers can be part of the cloud, or it can be different. So it doesn't matter. And then through the internet, we provide the results in dashboards to the clients. So this is an architecture which is followed. This is quite a standard architecture which is followed world over. For example, a company called Alstom, which operates locomotives in India, it has roughly around 30,000-40,000 locomotives. Their control center is in US, and from there it is monitoring all its locomotives and also advising the maintenance sheds, and also advising the drivers, control rooms. And if you look at the NASA, they also have similar kind of a system, of course more sophisticated. So this is the way, and we have to think that this will become the way of things, and all of us have to be geared for this. So now I come to the specific case studies of 4 types of rolling stock, that is the locomotive, coaches, wagons, and the Vande Bharat train set, we call it train set. So this is one electric vehicle. We have got many types of electric locomotives. So I'm just trying to, okay, you can do it. Yes, causing problem. So this is the project that is going on right now, and if you, this is a detailed estimate, but it gives you a very fair idea of what we're trying to do. So if you have, so what we are trying to find out the axle box. We are putting some accelerometers and temperature sensor on the axle box. So axle box is which is on the axle and the wheel, and there is a bearing, and that takes the load. So that is a very critical component of any rolling stock, because it is taking all the load. So by understanding its vibration, doing analytics, finding out trends, we can do diagnosis, we can do prognostics, and we can also do the health management, the complete health management. So every locomotive will be fitted with these 12 ones, because 6 axle, so every axle box on either side. Then traction motor, bearing monitoring, so this also vibration and temperature we are monitoring. And then we make use of those signals. And there are 3 ways. One is the alarm. The second is your diagnosis, if something is going wrong. And the last is the prognosis, remaining useful life. So let's say if the traction motor temperature is increasing, so you first tell the driver it is increasing, so he can cut off that traction motor. He can cut off that traction motor, and if he and then it can analyze and tell you, okay, things are going to become really bad, so he can even stop the locomotive, to put it very, very simply. Then we also have this track shock detection module here, which will, please tell me the time. Please tell me the time when I have to fast up. Professor Chaturvedi, just tell me the time. It's okay? Okay. So then we have track shock detection, because track plays a very important part in the safety of the train itself. Then we have all the data acquisition systems, edge devices, and so on and so forth. Then we also have this driver alert system. The last lecture by the professor from IT Madras, he was talking about the operator monitoring, and we are fitting these driver alert systems, camera algorithm on all our locomotives, because we have had many cases of signal passing at danger, which call is SPAD. So SPAD, to prevent SPAD, now we are going for this, and this will also have analytics along with it. Then we are fitting a fire and smoke detector monitoring unit. This is also already fitted in many of the locomotives. Then the other things are, of course, the accessories. But just to give you an idea that these are some of the sensors that we are fitting, and we are also using existing sensors like transformer oil temperature and voltage and current and pantograph and all those things. So we acquire the health parameters in terms of vibrations, temperature, voltages, currents. I think these are the things, and or shocks, and then we analyze that, and we find out whether there is going to be anything wrong, and even before it becomes bad, we are able to take care of it. That is one use of it. The second is that in case it is going to become bad, we inform the maintenance depot that this locomotive is going to give trouble, and it is going to have problem in this area, so be ready with these parts. Because I told you there is a contractual requirement to provide the availability has to be greater than 95%, otherwise there is a penalty clause on the companies. So for example, the companies which are running locomotives on Indian Railways, they give their locomotives 95% or grade, whereas our own locomotives, because we don't have a penalty clause in ourselves, it is around between 85 to 90%. That's the difference of having this. And this higher availability of 5%, 10% translates into thousands of crores of rupees in terms of revenue. So there's a bottom line attached to it. It's not a fancy thing that we are just monitoring something. There's a bottom line attached to it. Next, please. So these are the sensors. So this is a bogie. We call it as a bogie. Bogie is not, and generally we call coach as a bogie, but that's not the bogie. Bogie is which is beneath the vehicle that carries the wheels and all. So we will be instrumenting this bogie, various parameters, brake pressure and all that, and then monitor that, transmit it, and then analyze it and use it. Next, please. So this is just what we have fitted on one of our trials are going on. So as I say, this is not completely off the shelf kind of a thing, because every track, every rolling stock, and every interaction is different. So anybody having a rail wheel who works in rail wheel dynamics will understand that every such combination is a unique combination. You cannot just use the data in Europe, which is a standard gauge, to be used here. So we have to do a lot of analytics here, and it takes time. It takes 3 years, 4 years, 5 years. That type of a time period we have to look at. Next, please. So this is the vibration and speed sensor, just a close-up. So that one is this is the vibration sensor. It is a small sensor, and this is the speed sensor. Next, please. So these are the sensor specifications. So sensor specifications become very, very important, and they have to be really sturdy specifications. The sensors have to be very, very sturdy. For example, they are in dust, water, moisture, heat all the time. So IP67 or whatever, there are lots of standards there, dust proof, waterproof, shock proof. And we tested, for example, we tested one sensor on our 100, we fitted 100 our coaches, passenger coaches with these sensors, and we found in 1 year all the sensors were just broken because of the high vibrations. The sensor itself got broken. So the reliability of sensor becomes a problem for them. So we have to have a very reliable and very sturdy sensor in order to carry this out. Next, please. So this is the DAQ, data acquisition system, and the H box. This acts as it acquires the data and also does some kind of a local analytics, which can be simple FFT or onboard analytics, and then it will transmit the data to the radio tower. And we are also looking at a hybrid mode of communication. We are in touch with ISRO, for example. In Europe, it is going. It's called that, wherever I get a cellular network or a GSM, I use that. Wherever I get satellite, I use that. Wherever I get any other thing, Bluetooth, I use it, because it will not be wise to rely on only one mode of communication. And that people are realizing. If you go in a train, you will find at many places they're very sketchy or very, very low signals are there. Next, please. So this is the driver alert system that we also we saw Professor from IT Madras talking about. And so there's a facial image. This is going to be fitted on all the locomotives, all the driving cabs, wherever the drivers are there. There's also a simple thing. You have ECG and you have facial image and SDLP, data acquisition, fusion of various measures. Here again, it is not one sensor. There are a couple of sensors, and fusion of sensors becomes another important area. A lot of research going on in this area. Next, please. And then we have this fire and smoke detector and monitoring unit, in which we are able to predict. This is for the locomotive, but then this will be for the passenger coaches also. Some of the high value freight also. Next, please. Then we come to the train set, is 16 coach. Some of the slides may be repetition, but just to stress the thing. So this is the detailed estimate for the train set, and so we start again with the axle box bearing and traction motor bearing, that is temperature and vibrations. So these are very, very critical parameters. How to come to a conclusion about which parameter to measure is another science. So for that you need legacy data, you need domain experts, you need reliability experts. They sit down together, And there are software also. And then we decide, okay, these are the critical parameters which we have to monitor. Then we also do a gearbox bearing monitoring, track shock detection, and then of course the driver alert system, and data acquisition system and all that. So if you look at the cost of one Vande Bharat Express is 120 crore, maybe 125, 130 crore, that is 16 coaches. The cost of sensorization and data acquisition, hardware and software is roughly 2 crore. So if you take it in the terms of percentage, it's very less. But the advantage it offers is many times high, because the cost of the sensors is going down, but of course you need very, very steady sensors here, very, very good sensors, very reliable sensors. But the cost part is not as if that if my train set is 120 crore, I am going to put 100 crores worth of sensors, not like that. It is 2 crores. So next please. So this is the monitoring system diagram, again a fairly simple thing. So you have a microcontroller. This is one of the things I think from Europe. And then you have a microcontroller, you have a GPS module, then memory, then all these sensors are there, temperature sensor, signal conditioning, pressure sensor, extrometers, whatever sensors, and then you are able to acquire it and transmit it. Next please. Next. And these are the smart sensors on this is again bogie of the coach, the LHB coach that we are using. This is the major bogie, not exactly LHB bogie, I think it's some other bogie. Probably it is Vande Bharat bogie, yeah, this is Vande Bharat bogie. So you can see the location where we are putting the sensor. Locating the sensors is another issue. Where do you put the sensors? How do you put the sensors? For example, in the trial that we did, experiment that we did 100 coaches, there's a company called Perpetuum from UK. So they fitted these sensors on a kind of a cantilever kind of a thing. And due to vibration, it started, and all of them broke. So locating the sensor and then fixing it is also, it's a science by itself. Next please. This is again integrated DOK and edge box. Next please. Next please. Next please. Yeah. So this is the IoT or IT setup. So here we have the train control management system, and these are the data acquisition system. This is from SKF. So, but similar pictures are there whether you go for Perpetuum or SKF or X or Y or Z, and if you build our own, it will be similar to this. So this is a representative picture, not attributed to any company. And then from there you can have all types of dashboard, user views. And you can also take it to mobile, and you can find out the location. You can find out the health of your various assets. Next please. This is the same thing. Yeah. So this is for the pantograph. So here we are using the sensor, and sensor is this is FVG based, and from the FVG based sensors we are able to FVG is fiber Bragg grating. So this is a grating in optic fiber, and depending on the stress on the optic fiber, the wavelength of the light that it transmits changes, and from there you are able to find out what is the strain or stress in that particular part. So this is another field which has come up. We have just finished a very successful project with the IISc Bangalore and a startup from IISc Bangalore, where we are measuring the wheel impact load detection through the FVG sensors. So they are not, they don't have any problem of EMI interference or electromagnetic interference, and they are very, very reliable and very good repeatability, the FVG sensors. So FVG sensors, so sensors is a very, very big field which is coming up, and you will find thousands and if not lakhs of papers on different types of sensors, because this is going to pervade. After some time, I'm sure they will put a chip on my body also to find out my heartbeat and my mental status and all that. It is going to happen, because we are talking about very high speeds 500, 600 kilometers per hour, this, that. So sensors are going to be a very, very important field for all of us. Next, please. This is the pantograph monitoring system. So we have a ABG sensor, and then we also have a binocular vision. So this is a ABG signal processor, vision signal processor. Then we have a data switching, and then location line information. Am I doing something? Okay. So this is location and line information, and then we have these, server on the ground, data processing center on the ground, and diagnostic post. So this carries the diagnosis algorithm, and then onboard displays. It's a critical system. You'll find a similar system whether it is a locomotive or whether it's a processing industry or anything. So next. This is for the wagons. Now, if you look at the wagons, instrumenting the wagons is a very big problem, because wagons do not carry any power source. But there is a growing trend towards what is called as smart wagons. So they are saying that even the wagons have to be powered. And Europe is carrying out this smart wagon, smart trains, where the wagons are powered. They are self-powered and they are virtually coupled. So it gives you the advantage of a truck. So they are not coupled physically; they are coupled virtually. So a station comes, some of the wagons are the intelligent wagons, and some of the wagons will will get detached, go to that station, and they can be transported to the road to the last mile connectivity, as they say, and the balance they go. So it's a living organism. So it knows where to cut itself, where to add itself, and all that. They can travel their own? Yes, it's autonomous. Yeah, it is automatic train operation. It is, in fact, it is autonomous train operation. So they know which. So the route has been fixed. So it is level 4 of autonomous. They are running the engines? Yes. They have a traction, a small traction. It can be a battery, it can be a fuel cell, it can be a combination of both. It can even be a IC engine and combined together. Because they say that if you have to reduce the cost and give the last mile connectivity in train problem is that you can carry bulk, but the last mile connectivity is a big problem. You get down at a station, they will find for a taxi and all that. Or you have to then load it into a truck transshipment. So they say that if I have to compete with road, then I have to have systems where I can, from end to end, seamless transfer of goods and people. And that's the Gati Shakti is also saying, that by 2030, the Gati Shakti says that railway share in the freight transport has to be more than 50%. Right now it is 28%. Because railway is the most fuel efficient, energy efficient, most safe, and environmentally friendly. So, and Europe also, they had a very important program called Shift to Rail in 1998, and they started. It's now quite advanced, and they are going full out for the rail as a backbone of their shift to rail. They say that only railways can become the backbone. The road cannot, because road is very polluting, and energy wise is a guzzler of energy. So that is. Yeah, so they are basically virtually coupled. So if you have heard about platooning of trucks, so what they do that they travel together through signals being exchanged with each other, means Industry 4.0, that kind of concept. So everybody knows, and there are sensors to give the location front and back, and so they are talking to each other, and the goods or the freight that it has on in its belly, so that has got a digital tag indicating where it has to be offloaded. So from there it catches, and then the other wagons also know, because they are talking to each other all the time. Industry 5.0, you can say. There is no physical coupling. Not always. For bulk commodities, this is not required. But for white goods, like truck, what truck carries, there are certain goods which the railways are not good at carrying. They are not bulk, but they are high value items for that. Beg your pardon? That is also happening. That is RoRo. Yeah. RoRo is a there is no road there in Konkan. Only the railway line is there. Konkan Railway. Now RoRo is being started in many other routes also. From Havla also a lot of trains are happening to reduce this truck movement. Yes, sir. This is the future. This is the future of freight. Sorry, sir, you were asking something. It is not electromagnetic connectivity. It is a virtual connectivity. There is no attractive force between if the truck platooning, which is being tried out in many countries now. So what happens is that this truck and this truck, so there are certain sensors on either side, and which will help each truck to find out how far it is from each other, and it will talk to the microprocessor of one, will talk to the microprocessor of the other and tell it, okay, we are going this distance. There is no electromagnetic. It's a digital coupling, you can say. So there is no question of somebody coming and or somebody putting it off or that kind of a thing. But physical coupling also, the coupling that you see on the wagons, that is also going a transformation in terms of, it's called something called as digital automatic coupling. So there otherwise he has to pull that rod and then separate it. That also not required. So it decouples and couples by itself to reduce the time of coupling. And it is a very tough task. People get killed also. No, if he's not careful, then he's gone. It's a very high prone, accident prone area. In this case, in the virtual train, we are talking about every wagon is powered. Every wagon is powered by battery or fuel cell or hybrid of these. In a normal train, of course, that is not possible. Normal train gets coupled and it goes. Yeah.
Yeah.
So
Dr. Gautam, sorry to interrupt. Yeah, I think question answer again after the session, maybe lunchtime we will do.
Okay. Yeah. I'll quickly finish. I'm on almost the last slide. So we are developing a smart sensor because wagon has not been done earlier. There are few papers in US and in Australia, but we are working on that, and then we are going to do a proto, and then we do the field trials and all. So this is a research come development come commercialization, and so welcome any faculty or any student who wants to be associated. And sorry, please can you go back again? So the cost is per wagon is including the power pack is 10 lakhs. And the cost of the wagon is around 40 lakhs. So there also it is, but that wagon does not have anything right now. It's a very dumb wagon. So if I can increase my productivity, I can increase my revenue there. Next, please. So this is the smart. We'll fit this. Next, please. Next, please. So this is the sensor. This is a development. So there's accelerator, load sensor, temperature sensor. So the wagon, wherever it goes, be able to tell me what is the load on it and what is the vibration level on it. So I know its health. I can analyze it and find out. Next, please. This is the actual under development. Next, please. So this is the place where we'll put on the axle box. This is axle box. Put the sensor and then take the signals. Next, please. Now these are the coaches. This is the last part. Next, please. So here also, you see, one thing is very, very common. This is the bearings, acceleration, and the temperatures. So being done here also, and then crash shock detection. The shock can cause derailment, accidents, all that. But here there are more things here. Air spring pressure sensor. So these are the suspension systems which give us good ride. So we feel also there is a for derailments, accidents, and we are also looking at the air pressure brake pipe pressure sensor, because this gives the brake pipe, because braking distance depend. These are pneumatic brakes. We use pneumatic brakes. We have moved to electro-pneumatic also, but we have to look at the brake pipe pressure.
If some problem is coming, I think.
Okay. So we close it, or you can go to the next slide. I think that's the last slide, perhaps. Go again. Next, please. So please go back. So we are expecting that from 45,000 crore per year, we will reduce the expenditure on maintenance 20,000, and increase the availability of assets from 97 to 90% actual practice or standard, you can say. Zero accidents, zero train failures due to reliability problems. So with this approach, so it is a fusion of RAMs and PHM. With action plan, so integrated quality control, then one of the things that I wanted to mention, that we'll have to change our purchase practices. Right now, this open tender system and all that does not work, just not work. It will not work. So Deming says in his book Out of the Crisis that the American railroads were killed because of the open tender system. Toyota has only 100 dedicated vendors worldwide. They don't go to 101. Ford, General Motors, Toyota, they also have very limited tenders. For them, a vendor is like a part of the family. So our problem is that we are trying to do contract. Contract is not a contract, it's commitment. So we have to change the philosophy. I have spoken to the secretary of DIPP also, again a presentation on this aspect. I said, please change this, the way we purchase things. Otherwise, you never expect to get a good quality anywhere. If you look at the private sector, they don't follow this open tender system. That's how Maruti is able to give you Indian Railways not, because of the purchase practice. So I think with that, and this is we are also having this is the initial project that we will doing. We have a 400 crore sanctioned by the railway board. We are working on that. We are also doing bridges monitoring, track monitoring, and once we are having this pilot success, then we will go for wide scale implementation of all rolling stock. And the total cost we estimate, rough estimate is 10 to 15,000 crore. But the saving will be tremendous. You can see from 45,000 we are coming to 20,000. Per year saving is 25,000. So this is one time cost. So maybe 1,000 crore per year. Next, please. So this I'll close this presentation with two saying regarding purchase. So there is saying there is hardly anything in this world that some man cannot make a little worse and sell a little cheaper, and the people who consider price only are this man's lawful prey. As they say that sasta roye bar bar, this philosophy has to come in our ethos. If we continue to go for the cheapest and all, then we cannot improve the quality. We have to. And then another one, that you need to be rich to buy cheap products. Why? Because you eventually have to buy twice to have the job done properly. So this summarizes my purchase philosophy, and because purchase affects all of us, and it has to be transformed. Thank you so much.
Okay. Sir, Dr. Gautam is here in the lunch session also. So we are already overshooted by 15-20 minutes. I think excellent presentation, excellent lecture.
Thank you.
And in fact, from those who are in the core of safety, that there is 9 risk control systems. One of the risk control system is maintenance, and probably maintenance has the highest effect on safety. Mr. Sinha is there. Neeraj Sinha is there from Tata, and our Adani friends also. They know that we are teaching 9 risk control system. One of them is maintenance. Okay, so with this, thanks to Dr. Gautam, and we lunchtime we are giving you plenty of opportunities.
We'll talk.
And even in the valedictory session and the panel discussion time, Dr. Gautam is with us.
Yes, sir.
So you have plenty of opportunity. I am extremely sorry. I want to hand over to Professor Krishna for the next session. Okay? Okay. Big hand to Professor.
We'll be running here and there. Please
It's all right. It's all right. Please sit. Please proceed. बैठो तो उधर से चले जाना तो ना कम no, it's a pleasure to share the ideas.
Time we could not.
हेलो चले नहीं अभी लोग बुलाए
यहाँ बंद हो जा रहा है।
Gentlemen and ladies, please take your seat. We are starting our offline plenary sessions. Today's